Does that make sense? Now, always and never reissue, okay, always reissue is at least once, okay, never reissue is at most once. Those two things are synonymous. Okay. Now, we covered two-phase committed here, didn't we? Okay, let's review that real quick. I need to add that to the top of the The idea behind this is that if you have a number of devices and you're asking those devices to do something, okay, well, we wanna make sure that everybody is going to agree. This is what we call a transaction, right? Transactions are autonomous. That means that everybody executes this particular operation or nobody executes any particular operation, right? If everybody executes it, we say they come in. If even one node can't do what we ask it to do, we say that it has aborted. Okay? So if one node has to abort, one node can't do it, then everybody has to roll back, pretend like nothing happened. Okay? So basically what the coordinator has to do in this particular is, the coordinator has to say, okay, we elected somebody, we covered election algorithms here, right? So we have a coordinator. The coordinator in this initialization phase has already asked everybody to do something. So the coordinators and the participants, we have that action available. Okay? The coordinator's gonna send out that vote request. So with that particular vote request, what it is asking all the participants, it's saying, hey, are you guys prepared to actually commit this? Right? Can we do this? Is everybody on the same page? So when that vote request comes in, participant's gonna do one of two things. If for some reason it cannot complete that request, it's gonna say abort. Indicate abort, okay, well, the case is, if you indicate abort, you can immediately transition all the way over here to abort. Because if you can't complete that action, nobody can complete that action. Okay? So even one person aborts, everybody has to abort. Okay. If you can complete that particular action, okay, what's gonna happen is you're gonna transition into the ready state. Okay, you cannot just go ahead and commit because the coordinator has got to tell you. We don't necessarily know, just because we can't commit, we don't know that everybody can. And because we're not sure that everybody can commit, we gotta wait. So the coordinator is gonna send out that vote request and it's gonna wait. If it receives even one request that says we have to abort, it's gonna send out that global abort, it's gonna tell everybody participating, we can't finish this, everybody needs to give up. Okay? If we have a situation where everybody says we vote to commit, so everybody is voting to commit, at that point, what the coordinator is gonna do is gonna send out that global commit. And transition into that final stage right there. that commits. Okay. Now, the trick is, why we wanna do this is because if we're attempting to coordinate all of this stuff against a lot of different nodes, somebody could potentially drop off the network at pretty much any time. And because we can drop off the network at pretty much any time, we need to know how we respond in case we stop hearing from somebody, right? Because we can have a network partition pretty much whenever. So because we can have a network partition, we need to know how to respond when we start having timeouts. Okay, so there's a couple of lists of timeouts here. So let's just kind of walk through those. First timeout, okay. Let's say the participants are in the initialization phase. They are ready to do whatever the coordinator has asked them to do. If they are sitting in that particular phase and they never actually hear the vote request from the coordinator, well, they can go ahead and abort. And the reason that they can do that, well, if you never heard the vote request, you never could have voted. If you can't vote, you couldn't have voted to commit. And if everybody has not voted to commit, well, then everybody can. So if you time out in the initialization phase, you can't commit. If you didn't vote to commit, so everybody just goes ahead and votes. Okay. Coordinator could be stuck waiting for votes. So it just asked everybody to vote, okay? And at that point, while it's asking everybody to vote, one of the participants has dropped off the network. At that point, you have to tell everybody to abort. Could that participant that dropped off the network, did it vote to commit, or did it vote to abort? We don't know. So if everybody can't commit, everybody has participant before they have told us definitively, we have to assume that they can't complete the action. Okay, so we assume we can't complete the action, we go to local board. Okay. The trickiest thing is if all the participants are in this particular stage, they're in the ready stage. So we could have a situation, the coordinator drops off the network when the participants are already in the ready stage. If they're already in the ready stage, what does that mean? How do you have to transition into the ready stage?
They've gotten a vote, they can commit, and they've sent their vote back to
Right.
the coordinator.
It means that they have voted to commit. So if everybody has voted to commit, and then the coordinator drops off, we have a problem. Okay? So if we are stuck in this particular ready phase, what we are going to do, we're gonna start checking with other participants. We're gonna see who's left on the network. When we check with other participants, if we find a participant in the initialization phase, okay, we know that that participant never voted. If they're in the initialized phase, they never voted. Okay, if they never voted, they could not have possibly voted to commit. And because they didn't vote to commit, well, we got to award. Because everybody got to commit, or we all. If we find them in the commit stage, that means that the coordinator actually told everybody to go ahead and commit. It sent out that global commit command. For some reason, you just didn't get that command. So before it sent you that particular message, it dropped off the network somehow. So somebody got it, because you can't transition to commit unless the coordinator tells you. Right, so the coordinator told everybody to commit, for some reason you just didn't hear it. So if you find somebody in commit, just go ahead and commit. You're good to go. If you find anybody in a board, for whatever reason, maybe the coordinator told them to abort, maybe they timed out at the initialization stage, but if you find anybody in the abort stage, at that point, you have to. One node aborts, everybody has to. Bad thing here, if every single node in the network, every participant in the network is in the ready stage, you can't figure out what to do. Okay, so you can actually be deadlocked in that petition, for instance. Okay, it is extremely unlikely that would happen in practice. This is happening over the course of, you would hope, a couple hundred milliseconds, right, a couple tenths of a second. So for everybody to vote and the coordinator just happens to disappear after everybody has already responded to it, that's really, really unlikely. However, we kind of go back to that whole safety criteria, right? If this is an airliner, well, we don't want the thing dropping out of the sky if this extremely unlikely thing happens to happen. To prevent that extremely unlikely scenario, we end up having what we call three-phase commit protocols. I'm not worried about those, there's a lot of different ones. Okay, but there are ways to avoid that particular problem. However, because it is so unlikely, the two-phase commit is really much more common here around now. Okay. Questions on that? I need to add that to the topics of interest because I've covered it. Okay. So any kind of questions on chapter 8? Yes.
So you said if one is in abort, you abort. If one is in commit, you can commit, because that means that the coordinator would have sent that command out to everyone.
Correct. You can't transition to commit until you hear from the coordinator. So what that means is everybody voted to commit, and the coordinator transitioned to this page right here, was telling everybody to commit, and for some reason, you just didn't hear it.
Okay.
So unless the coordinator has said commit, and if the coordinator says commit, everybody voted to commit. So everybody voted to commit, you just didn't find out about it. So at that point, if they're in commit, you can go ahead and commit as well.
But if everyone is in, if you check all the others and they're all in ready, then you're deadlocked.
Yeah, you're definitely.
What if you and one other is in ready?
If you're the only two in ready, well, then somebody's going to be in some other stage.
Okay, as long as someone else is in commit or someone else is in abort, you can make a decision.
Yeah, you can be in the initialization phase too. Everybody has to be right there. And if they're right there, you can't really make a decision. You gotta wait for the coordinator to come back online. Okay, rejoin that. Other questions? Okay, questions about the papers that I covered, the answer sheets for those papers. You guys got the answers from that? Good to go? Any kind of questions on that stuff?
You said there was an answer sheet, sorry?
Those answer sheets are for the discussions.
I guess, I don't know if I missed that on Blackboard. I must have missed that on Blackboard, I'm not.
Yeah, out of the discussion folders on Blackboard.
Okay.
Yeah, there's the papers and there's questions about that.
Gotcha.
Okay. All right, so for you guys that have already presented, please make sure you upload the answers to your questions at the end of your PowerPoints, because I'm gonna write the test in the next couple of days, so I need to be sure to have those. Okay, so just go ahead and upload it. You're not gonna get a grade on it, that's just a place for you to keep it. Okay. If you modified your slides, and they were different than the slides that you actually presented, please make sure to put those on Blackboard as well, because people need those to study. Okay, so questions on chapter 8, questions on the lab?